The period between 1995 and 2015 was considered the golden age of Intel. Back then, just a computer chip powerhouse licensing its x86 architecture left and right to companies such as Microsoft, Apple, Hewlett-Packard, IBM, etc. And you couldn't go without seeing those famous stickers of their models on almost every computer around. So, how on earth does such a giant get embarrassed by a phone company?
And so it's time for a third transition, and yes, it's true. We are going to begin the transition from the PowerPC to Intel processors, and we are going to begin it for you now and for our customers next year. Now, why are we going to do this? Right? Didn't we just get through going from OS 9 to OS 10? Isn't the business great right now? Why do we want another transition? Because we want to be making the best computers for our customer looking forward.
The battle for supremacy between ARM and x86 architectures is still shaping modern computing today, but with Apple making strides in the chip industry, the insane success of Intel has become its own downfall. In this video, we'll answer what the chip war actually is, how Intel fell out of its golden age, and why Apple Silicon caught them off guard. So, sit back and relax as we take a deep dive into the decisions behind the industry.
But first, we have to define what this battle was. It didn't originally start as Apple versus Intel, but Apple did license chips from Intel for the first MacBooks. In my last video, I talked about what CISC and RISC were and how they led to the rise of the two dominant processors of today, ARM and x86. But I didn't talk much of how they came to be each other's competition. There was a clash of ideologies, more so power-packed chips for personal computers versus smaller, more efficient chips for smaller computers, also known as smartphones.
This symbol outside means you have the standard inside that an entire library of software has been written to. The Intel microprocessor. Think of it as a library card that lets you run the software of today and tomorrow. So check out Computers with Intel, the computer inside.
Intel sold chips to everyone. This was a good thing. Selling products to a wider audience naturally translates to more business for your business. And the strategy worked. Just like the Windows operating system, Intel chips had become ubiquitous for over 2 decades, spanning the late 90s to the mid 2010s, powering high-end personal computers with a focus on backward compatibility, making it possible for software written decades prior to run on modern hardware. The company's best work in this aspect was their x86 series.
Although the company would end the era of outsourcing chips to external suppliers in 2023, under Steve Jobs, the seeds of such a transition were planted in 2010, when the company introduced the A4 chip for the iPhone 4 and first generation iPad. This signaled to consumers and suppliers that the company was headed for a more self-reliant path.
Despite keeping its chips exclusive to its own products, like it did with its operating systems, there wasn't much of an issue, as the company had built such a loyal fan base that proved building a walled garden to be an essential part of the company's image. It prioritized the user's experience over all else, optimizing for battery life, heat dissipation, and of course, making its designs as thin as possible before a gust of wind could smash them in half. Ironically, keeping their chips exclusive to their platforms supported the amount of control they had over the user experience, often earning them a better brand reputation than competitors among regular and aspiring customers alike.
Still, this was during Intel's golden age, so how did Apple come out on top in the end?
The dominance of Intel in the industry at the time was built on 3 pillars: a monopoly in the form of Windows and x86, horizontal scale, and a dependence on Moore's law. When Microsoft first sold MS-DOS to IBM, it successfully negotiated a non-exclusive deal that would allow it to license the software to other computer manufacturers, leading to Windows gaining a worldwide presence rapidly. Because of the backward compatibility of its instruction set and universal presence, x86 became the default for personal computers. The two had become inseparable, and since enterprises frequently used legacy software, the duo was the way to go.
The horizontal scale came from having one architecture with millions of customers. With such a large base of people throwing money at you, came massive profit margins, and with massive profit margins came a lower appetite for risk. After all, why would you want to harm the model that is making you this much money? Part of this model was Moore's Law.
I was asked by Electronics magazine to predict what was going to happen in electronic components in the next 10 years. And we were making integrated circuits with increasing complexity, but not very complex. The first ones had about 4 components on it. A year later, 8. And I plotted this out, and I thought, geez, from the introduction of the first planar transistor in 1959, the complexity on a chip had about doubled every year, and it was getting up towards 60 when I looked at it in 1965.
In 1965, Intel co-founder Gordon Moore, working at Fairchild Semiconductor at the time, predicted the number of transistors that could fit on an integrated circuit would double every 2 or so years. Sure enough, he was right, and transistors became smaller and smaller, and the power of Intel's chips grew exponentially with each reduction in size. Between 2012 and 2014, the span of 2 years, Intel had gone from producing 22nm processors to introducing a 14nm chip. Even after delays in 2024, the company switched to ASML's high-NA extreme ultraviolet lithography machine that could print out transistors the size of 2 nanometers. For perspective, a nanometer would be a billionth of a meter, smaller than the wavelength of visible light, or roughly 2 to 4 times longer than the diameter of an atom.
Intel had the best possible problem one could have: too much success.
The chipmaker had gambled its industry leadership on Moore's Law, a statement that was an observation, not a physical law of science. Naturally, as transistors approach the size of literal atoms, the cost and time taken to produce these little guys would catch up to the company, and that's what happened when Intel placed a bet on reducing the size of its transistors to 10 nanometers and below. It was meant to launch its new chip in 2016, but it had broken its promise of reliability to customers when the release was pushed to the following year. The following year, the company's image had taken a hit, and the chip was released in 2019, albeit in limited, unpolished batches.
Moore's Law is nearing its physical limit, predicted to meet the end of its logic by 2036, and true 10nm silicon is predicted to arrive as far as 2039. The wrong bet had dismantled the company's leadership, and it lost it to the dominant force now being Taiwanese-based TSMC.
Apple had ditched Intel at this time, but they designed their entire system, not just a CPU. This is where their silicon chips had caught Intel off guard.
Systems on a chip are more than just the CPU. They are the full package, having all the major components of an electronic computer: CPUs, GPUs, RAM, media encoders, compilers, and much more. Apple created an ecosystem for its ecosystem, with the full control over the software and hardware on the platforms it's built that it had.
With the experience in semiconductor manufacture gained from its A-series chips, the M1 debuted in November 2020 as the Intel Killer. It was a result of a close relationship between Apple and Taiwan Semiconductor Manufacturing Company, or TSMC, the world's largest chip manufacturer. Intel had become a sunken giant at this time, losing to other companies such as Nvidia going into the decade.
At this point, you might think the most logical move for Intel would be to copy Apple. Well, it's not so simple.
Apple could change macOS or its hardware overnight if it wanted to, but Intel can't control Microsoft or any of its OEMs. Intel did not sell directly to consumers, and its business model had relied on clients it had no power over. It would have been like trying to force Windows to be redesigned around new Intel chips, which is not going to happen.
It's hard to imagine a future where iPhones have Intel inside, but that was almost the case prior to 2010 when Steve Jobs had met with then Intel CEO Paul Altalini. Let me try to remember the story here, but Jobs had essentially decided to meet up with Intel to potentially get ARM chips for the iPhones. But Altalini at the time, he rejected the offer, citing that it would cost billions of dollars for so little in return on investment, even though he missed that potential return on investment by over 100 times. Yeah, very costly mistake for Intel. But now we see Apple creating its own chips, and Intel, it's in the dust, essentially.
While Intel did lose the war to Apple, it isn't dead. Despite setbacks the companies faced in recent years, it is still becoming more profitable than ever, even experiencing a surge in sales during the pandemic, when consumers purchased more laptops with Intel inside. It still sells millions of CPUs annually and dominates enterprise applications, but the industry is no longer a core.
Regardless of whether you use Apple Silicon or AMD Ryzen or are more into GeForce GPUs, it's hard to deny that Intel has served as a valuable example of what not to follow for these companies.
But that takes us to the game at large, a battle between architectures, ARM versus x86. If you want to know how both rose to fame and became the philosophies of Apple and Intel, then you can dive into the impact this battle has had on the industry by clicking this video. Thanks for watching.